Okay, so for pre-calc 20, today we're going to start chapter 5 of the textbook. So this is radical expressions. So, working with radicals, we did this in Foundations 20. So a radical, remember, is anything like this, with the square root sign. Okay. Do you guys remember some of the terms from this stuff? What's that? Like, do you remember, like, this is your radical sign? You guys remember what the number under the radical is called? Radicand. Radicand. Yes. Just catch a little slogan that comes up with the radicand later on. Yeah, the radicand. Okay, so we'll be working with stuff like this. So stuff we did in grade 10 is I would give you something like the number 200. Like, what's the square root of 200? 200 is not a perfect square. What's that? So you would break it down. Remember, I always said to find factors, use factors and numbers you know the square root of. So I know that 200 is actually 2 times 100, right? And we know the square root of 100, don't we? What is it, Chloe?
10.
Very good. Square root of 100 is 10, so you take that out, put the 10 out front. I don't know the square root of 2. Guess what? That one's done. Okay. This here, when you have a number and then a number under the radical, a radicand, this is known as a mixed radical. This here is known as an entire radical.
Maybe like any factors of 200, or is it?
Well, if you do any factors of 200, like another way you could have done it, you know 200 is also 10 times 20, right? Do you know what the square root of any of those numbers? No. But, so that's no good. But you do know it's also 50 times 4. You know the square root of 4, right? So this becomes now 2 root 50. We also know that 50 is 25 times 2. What's the square root of 25, guys?
5.
Right, so you bring the 5 out, so you go 2 times 5, which would be 10 root. So it's the same answer, just a few extra steps. So you're not wrong in either route you go, okay, Sam? You just got to be careful.
Wait, 25. Why do you have a 2 on the?
On the inside?
Oh, because now you're doing 2 on the outside and then with this.
Right. Brennan, you better not get any goldfish crumbs all over that floor. Okay, that's what I want to hear. Or leave them on your shirt. I don't want to be seeing this or anything, okay?
That's not going to happen.
I got that broom there. First I will get you to sweep the floor, and then I will whack you with this. All right?
Well, great thing to say when you're
I got that recorded, so it's on the record.
Is that a good thing?
It's not a bad thing.
That you're gonna whack someone?
It's fine. All right, so let's do another example. Sometimes the textbook likes to do things like 48x cubed. Right.
You could find a third, whatever it is.
So just okay. Factors of 48, I know the square root of. So try 4 if you want. Try 9.
It's just 170. But that's not.
No. 8 times 7. No, 8 times 6.
I was thinking of 28.
I would go with 68 times. Oh, sorry, 16 times 3. Now, break this down. X cubed is x squared times x, right? Yeah. So you got to break those. Break your x cubes down, or break your variables into smaller x squareds. The amount that you can write it as. So now I look. Okay. Square root of 16 is 4. What's the square root of x squared?
X.
Now everything that's left stays under the radical. 3x.
Oh.
Cool. Let's do another one with nothing but with bigger ones here. Let's try square root of x to the 9.
What about when we have to do like the tree? Like,
No trees this year. Pre-calc 20 is no trees. Adults don't do trees. All right, now x to the 9, that's just x squared times x squared times x squared times x squared times x. Right? What's the rule for exponents when you multiply? You add the exponents, right? So if you add this up, 2 plus 4 plus 2 plus 2, or sorry, 2 plus 2 plus 2 plus 2 plus 1 is 9.
There's 2 like that?
Well, square root of x is, square root of x is, all right, square root of x squared is x, square root of x squared is x, square root of x squared is x again. So you take the square root of each one of these. And then what's x times x times x times x?
Get real confused.
For whatever reason, these ones here are the hard ones for people. Another way you could look at it is, like this is square root, right? So technically there's a 2 there. Right? Right there, square root. Normally there's a 2 there, you just don't write it. How many times does 2 divide into 9?
like decimal?
No, just like 2 would go into 9 4 times. And what would be the remainder? 1, x to the 1. So you could do it like that too. Okay, these will take a little bit of practice. What if we wanted to go the opposite now? What if we wanted to go from a mixed to an entire radical? So let's say I have something like root 7, or sorry, 7 root 2.
Just say 49.
Well, Yeah, it would look like this. You took the square root of 7 to bring it out there, right? So what's 7 squared? 49
20 times by 2.
times it by 2. That's going to be root 98. Okay. How does that feel? Well, that's because they're all easy. Oh, okay. Oh, all right. Let's.
I was going to use that against you.
Yeah, let's do something a little trickier now. Let's go 5. X squared radical 3x. So you took the square root of these to bring them out of the radical. So you do the opposite and you square everything to bring it inside. Like, right, we took 7 squared and made it 49. So you do the same thing here. If you want, write it out like this. Take what's outside the radical, put it in, and then square it times 3x. Does that kind of make sense? Adam, makes sense? I like that head nod confidence. Serious swagger. So 5 squared is 25. X squared is x to the 4, Mr. Weber. Thanks, guys. Times 3x. Then you just multiply it all together. 1.5 x to the 5th.
Oh, you added.
Yeah, you got to add them. I multiply here, and then add here. All those darn exponent rules that I made you guys learn last year are coming back to haunt you.
So you do times 25 by 3 and then you added x's.
Yeah. The rule for multiplying exponents is you add the numbers up.
Oh, yeah.
Okay.
Yeah.
Now that we've done a little review,
Is that an exponent 5 or is it a big number 5?
exponent 5.
I know why that's not square because this is
All right, so now we're going to add and subtract radicals. So when you're adding and subtracting, I always think of it like fractions. With fractions, when you add and subtract, the bottoms have to be the same, and you only combine the numerators, right? Here it's kind of the same, except we're not dealing with a fraction. So, in order for this to happen, the radicands must be the same. Right? That's like your common denominator. And if they're the same, then combine the coefficients or numbers out front. Wait, what?
I've combined the numbers.
I don't
Then combine the numbers out front. You shouldn't understand what I'm talking about right now if you haven't seen it before, right?
Sure.
No, you shouldn't. Of course not. That's ridiculous. I'm not unreasonable here.
So if they are the same, then.
Then you combine. If they're not the same, guess what? You don't do a thing. Leave it alone. I'll be there in 5 minutes. Can you move on to the next question? You know what? I'll be right there. It's not that bad. Let's do a couple of examples here. Real simple one to start with. 3 root 5 minus 8 root 5. These are two numbers. So
Plus or subtract?
subtract. So are my radicans the same?
Yeah.
Cool. Guess what? You just combine the coefficients or numbers up front. What's 3 take away 8?
-5.
Very good. The radicand stays the same. So it's kind of like your common denominator when you do fractions. You don't do anything to it. How's that? Pretty easy, right? I'm pretty sure you guys at this point can tell me if 5s are the same and then how to do simple subtraction or addition. Right? It's not too bad. We count 20 so far. All right, let's try another one. Now, of course, it's not going to be this easy all the time. If that was the case, I probably wouldn't need. I wouldn't have a job. I wouldn't need to be here. But what if we had something like this? Root 50 plus 3 root 2. Now I already know that you guys know that 50 and 2 are not the same number.
Yeah, 50 down.
Whoa, Chloe, George. Mic drop. Did everyone hear what she just said?
Get it down.
We can manipulate the 50. It's 2. Right? Because we know 50 is 25 times 2 plus 3 root 2. Boom, boom, boom. What's the square root of 25? 5. Right, so this becomes 5 root 2 plus 3 root 2. Then we can combine stuff. 8 root 2.
That's all I did.
Done and done.
I don't know why you wouldn't. Maybe because this is.
How are you feeling so far? Pretty good. Thanks, Sam. Everyone else is kind of like, sometimes. Don't. Let's try a harder one now. Negative root 27 plus 3 root 5 minus root 80 minus 2 root 12. A lot going on there. It's a busy solid.
Salad?
Yeah. I heard a kid say it one time. Here's the salad.
It's not the same.
Now, can we manipulate those? Remember to always use factors you know the square root of. So would I factor 80 down to 8 times 10? No. I would look at it like this. Okay, like 27. 27 is kind of an easy one because there's only two things that you can multiply together to give you 27. And that's just going to be 9 times 3.
But that's not 5.
No, it's not 5. Let's talk about that in a second. Can I factor 5 down to anything? Nope. That's going to stay what it is. Now, 80. I'll do this one first, and I'll go back and explain how I knew how to do this. I know 80 is 16 times 5.
I'm just trying to get them the same.
Right, I'm trying to get them the same. I know I'm going to try to look for 5. Okay, so that's where I'll go with this.
I know what you're trying to do.
Now, don't ruin the ending, Maddie. No one likes to spoil it. 12 is just 4 times 3, right? 6 times 2 won't give me anything. Now, okay, let's take some square roots. Square root of 9 is 3. 3 root 5, nothing to be done with. Square root of 16 is 4 root 5. Finally. Oh, hold on. Bring it back. Slow down. Square root of 4 is 2, so 4. Am I going too fast? Does this make sense? Oh Lord, make that make sense. Thank you, Sam. That's all I need. Just a little bit of feedback here.
You said, do you just change the 4 to the 2 to a 4?
Well, I take square root of 4 is 2, right? So when I bring the 2 out, I multiply it.
But you add them, you multiply.
Yeah, I multiply.
Why would it be 8?
No, square root of 4 is 2.
2
Times 2.
Oh, I was timesing.
Yeah. 2 times 2 is 4.
But also 2 plus 2 is 4.
Yeah, I know. 2's a bad one. I get it. Okay, now. Got this simplified. These two radicands are the same. These two radicands. So that's all I can combine there. So, for my root 3's, I got -3 and -4. That becomes -7 root 3. 3 take away 4 becomes -root 5. You could put 1 root 5, but it's kind of weird. You just say it's root 5. You're not wrong, you're just weird. Yeah.
So that question we were talking about, it's supposed to equal cosecant x.
Okay, give me
I don't know how to get it there.
give me a
And I'm struggling.
okay. Either move on to the next one and I'll come and I'll do it on the board right away. Just let me get these guys their assignment. And then all right, questions, concerns, thoughts, inquiries? Cool. All right, here's your assignment for today. Boys and girls, on page 279. 78, sorry.
You just drew a snake.
Yeah, whatever. Number 2. Number 5. It says to explain your strategy. Don't do that. Just do the question. 8, 9.